we are looking at a system of linear equations. So we have two equations here. They're linear. As you can see, the degree on the x variable is 1, the degree on the y variable is 1. Therefore, they're linear equations. The graph of these will be a line. So if you look at the first equation, if we graph this, think about if you put a 1 in there for x. So I'd have 3 times 1. So 3 plus what equals 5? Well, 3 plus 2 equals 5. So if x was 1, y would be 2. That would be a point on the graph. If you let x equal 0, 3 times 0 is 0, plus what number equals 5? 0 plus 5 is 5. So if x was 0, y would be 5. So let's actually look at the graph of this. And the way to get the graph of this is to actually solve it for y. So all I'm going to do is subtract 3x from both sides. And if I do that, I get y equals negative 3x plus 5. Now, a real cool tool to use is Desmos. So I'm going to type that equation into this grapher. So we said y was equal to negative 3x. So there, right there is the graph of y equals negative 3x. And then it was plus 5. Whoops. Plus 5. Notice what that did, it just shifted the graph up 5. So remember we said when x was 0, y was 5? There it is, there's the point right there. We said when x was 1, y was 2. So when x is 1, right here, y is 2. That point right there. So this is the graph of that line. So let's go back to our screen. We're going to graph two lines. So I'm going to do the second one. I'm going to solve it for y. I'm going to subtract 2x. So I have negative 3y equals negative 2x plus 18. Now I got to get rid of that negative 3. The way I'm going to do it, I'm going to multiply both sides by negative 1/3. Whatever you do to one side of the equation, you have to do the other side of the equation. It balances itself out. So what does that leave me with? This negative 1/3 times negative 3. A negative times a negative is a positive. 1/3 times 3 is 1, so that gives me y. And over here I have negative 1/3 times negative 2x plus 18. I could multiply that through if I wanted to, but all I want to do is look at the graph of this. So I'm going to graph this. I'm going to go back to our Desmos, and I'm going to click here. I'm going to enter that graph. So it was parentheses negative 1/3, so negative 1/3, and then that was times parentheses 18 minus, or negative 2x plus 18. And notice we have that purple line. So notice these two lines cross, and that's the solution that works for both of those equations. In other words, if I plug 3 in for x, on both those equations, my output is going to be -4. The two lines cross. Now there's three possibilities when you're talking about a system of equations. When you graph two lines on here, there's three possibilities. One possibility is this: the lines cross and there's a solution that works for both. There's a point that satisfies both equations. The lines intersect. Okay. The other possibility is the lines are parallel. They have no points in common. The lines have the same slope but a different y-intercept. They're parallel. No solution. The third possibility is you graph the first line and then you graph the second line and they turn out to be the same line. So that's an infinite number of solutions. Every point on the line is a solution for both equations. So when you graph these, remember, or you solve a system of equations, when it's two linear equations, there's three possibilities. One solution, that means the lines cross. The lines have different slopes. They have to intersect. Second possibility is the lines have the same slope, so they're parallel, so there's no solutions. And the third possibility is the lines are the same line. If you solve the equations for y, you'd have two identical equations. And in that case, there's infinite solutions. So let's go back to our sketch here. So one way to solve a system of linear equations is to graph it and look where the lines cross. Okay? And there can either be one solution, no solution, or infinite solutions. The second way to solve these is, you know what, let's write down the solution for this. Right here. That solution was 3, -4. The solution was 3, -4. Let's just check that to make sure. Let's take this first equation. 3x plus y equals 5. We're saying that 3, -4 is a solution to both of those equations up there. So if I plug in a 3 for x and I plug in a -4, whoops, I was going to change the color on that, but that's okay. So if I plug in a 3 for x and a -4 for y, it's supposed to equal 5. Well, 3 times 3 is 9. 9 plus -4 is 5. And that's what it's supposed to equal, right? That's it. It's supposed to equal 5. The second equation up there is 2x minus 3y equal 18. So 2 is supposed to equal 18. There, we'll change the color here. So I'm going to plug in a 3 for x. I'm going to plug in a -4. That's a 4. A -4 for y. It's supposed to equal 18. So 2 times 3 is 6. And then -3 times -4. Negative times a negative is a positive. That's 12. 6 plus 12 equals 18. And that's what it's supposed to equal, 18. So you can see that 3, -4, that right there, 3, -4 is a solution that works for both equations. Of all the billions and billions, infinite numbers or ordered pairs there's only one ordered pair that works for both of those equations, and it's 3, -4, and we found it by graphing. Okay. Well, there's another way. There's two other ways to solve this. So we're going to look at both those ways. So when you solve a system of equations, you can solve it by graphing, and another way to solve it is by substitution. So I have 3x plus y equals 5. My second equation was 2x minus 3y equals 18. So if you're going to solve by substitution, what you want to do is you want to take one of the equations, solve it for one of the variables, and then plug it into the second equation. So I'm going to take the top equation there. I'm going to solve this for y. We already did it earlier, right? So I'm just going to subtract 3x from both sides. So I get negative 3x plus 5. And then what you're going to do is you're going to take this and you're going to substitute it in to that equation right there. So you have 2x minus 3. You're going to plug that in. Negative 3x plus 5. All I did is I replaced the y with what y equaled from the first equation. That's it. And this is equal to 18. Okay? Again, I took this y out right there and replaced it with the red, what y equaled from the first equation, negative 3x plus 5. Now simplify this. I'm going to multiply through by negative 3. So negative 3 times negative 3x is plus 9x. And then negative 3 times 5 is negative 15 equals 18. Simplify. Notice now we have one equation with one unknown. We can solve for x. Originally we had two equations with two unknowns. You can't solve those and get an answer. But if you have one equation with one unknown, you can solve it and get an answer. That's why we did that substitution. So now we have the equation written in terms of just x. So 9 plus 2 is 11. I'm going to add 15 to both sides here. I get 11x, 15, and 18 is 33. Divide both sides by 11. And you get x equals 3. Remember? Look at 3. We knew it was going to be 3. So what's y going to be? Y is going to be negative 4. How do I find y? Take that equation you have at the top where you have, it's in red, so let me write it in red down here. We have y equals negative 3x. Remember I took the first equation, solved it for y? So you're going to take that first equation that you solved for y and plug in a 3 for x. So you get y equals negative 3. And you're going to plug in a 3 for x. So that gives you y equals negative 3 times 3 is negative 9. Negative 9 plus 5 is negative 4. So your solution is 3 comma negative 4. How do we find it? We found it by substitution. We took one of the equations, solved it for one of the variables, and then plugged that into the second equation, the other equation. And what we're left with is one equation with one unknown. You can solve that equation for that unknown, and once you find that, that's what we found, x equals 3, then you plug that x equals 3 into your original equation and solve for y. Notice we got the same thing. So that's solving by substitution. Substitution. This over here, we use Desmos, and we solve by graphing. You could do it on a graphing calculator. There's all sorts of online resources, but we use DEM Desmos. Okay. Whoops. Third way, the addition method. And then we're done. So you can solve a system of equations, system of two linear equations by graphing, by substitution, and by the addition method. Let's change our color here so we don't. Let's just do black. So our first equation was 3x plus y equals 5. Our second equation was 2x minus 3y equals 18. So what we're going to do is we're going to add these two equations together. But we want to add these two equations together so we end up with the same result that we had over here, where we had this equation right here. We had one equation with one unknown. So I want to add these two equations together. But what I want to do when I add these two equations together, I want one of the variables to drop out. So I'm left with one equation with one unknown. And to do that, I'm going to take this top equation right here. I'm going to multiply it by 3. Why 3? Because if I take 3 times this y, I get 3y. Notice I have minus 3y down there. So if I add the two equations together, the y's will drop out. So what I'm going to do is I multiply both sides of the equation by 3, which means I multiply every term by 3. So if I take the top equation times 3, I got 3 times 3x is 9x. 3 times that y is 3y. 3 times 5 is 15. Again, I just multiplied both sides of the equation by 3. As long as you do the same thing to both sides of the equation, the solutions, you'll get what's called an equivalent equation. It doesn't change the solution. So my second equation was 2x minus 3y equal 18. Now, I can add these two equations together. If I add these two equations together, notice I have positive 3y and negative 3y. That's 0. That's 0y, which is 0. So 9 plus 2 is 11x. Anybody want to venture what the answer is going to be here? 15 plus 18 is 33. Does that look familiar? And I'm going to divide both sides by 11. And I get x equals 3, which is what we had right over here. Look at it. So, but I solved it an entirely different way. I solved it by addition. I added the two equations together. But before I added the two equations together, I multiplied the top equation times 3 so that I had one of the variables had coefficients that were opposites. So when I added the two equations together, that variable dropped out. Now, take either equation. Doesn't matter which one you take, and then plug in x equals 3. So I'll take the top equation. I got 3x plus y equals 5. I'm going to plug that 3 in for x. So I have 3 times 3 plus y equals 5. Anybody want to venture what the answer is going to be? So 3 times 3 is 9 plus y equals 5. Subtract 9 from both sides and you get y equals negative 4. Same solution. When x is 3, y is negative 4. So this is solving a system of equations. How do you solve a system of equations? Really cool to do it by graphing up here, right? Desmos is a good utility to use to help you get it. But you get a visual picture of what's going on if you graph it. Remember, if the lines cross, there's one solution. If the lines are parallel, there's no solutions. If the lines are the same line, then there's infinite solutions, right? All the points on the line are solutions for that system. The second way to solve a system of equations is by substitution. Take one of the equations, solve it for one of the variables, and then plug that into the second equation. Okay? And then you'll have one equation with one unknown. Solve it, get your answer, and then plug it in. You can plug it into either equation. Third way is by the addition method. You're going to add the two equations together. But before you add the two equations together, you got to manipulate those equations. So one of the variables has coefficients that are opposites. So when you add the two equations together, that variable drops out. This concludes solving a system of equations by 3 methods: graphing, substitution, and addition. Please sit down. No standing ovations. Thank you. Thank you. Thank you.